Welcome to this lesson, and I hope you've had a great Easter. So, in this video, we're going to look at how to write clean and modular Python code. So again, whether you're just starting out or you've been writing some spaghetti code for a while, this video is going to help you write Python, clean Python code. And yeah, let's quickly get into it. So first of all, what does modular mean? Modular means breaking your program into smaller and manageable parts. So usually you can use functions or you can use files, but just breaking your program or your code down into parts that are smaller and manageable, so that each of these parts can do one thing, and it can do that one thing really well. So it basically, as a result of that, it makes your code a bit easier to read, easier to debug, and easier to basically reuse later on. So we're going to go to our code editor, and I'd like us to write some code that is not modular to begin with. We can have a simple print statement here. I've created a file called modular.py, and here we can print a statement that says maybe hello, what is your name? So let's say this is our first message, and we can now pick an input from a user. So we just use input, the input function, and then we can print out basically that name. So in this case, you can just use a simple f string, and you can say nice to meet you, then the name of that person. So you can just say nice to meet you, and we pass in the name like that, and we will probably need a comma here like that. Okay, so what you can see here, this is code that is not modular. Again, it does not mean that the code is not going to work. It is going to work if you run this code. Okay, let's redo this again. So you can see, and what is your first name? Let me say Jack. Then you can see, hey, nice to meet you, Jack, right? So the code is still working, but this code is not modular. Like you've mentioned, modular means that this code has to be reusable, and it basically needs to do one thing really well. So how we can go ahead and make this code modular? So I'll actually just add a comment up here, and I'll just say not modular. So we're going to write some code here that is modular, and in this case, we're going to write a simple function to, again, this is what we talked about functions. Functions help us modularize our code, and a function is good when it only does one thing, and it does that one thing really good. So you can just say maybe the function, we'll call it greet user, and the function can take in a parameter or not. Then you can have name. So actually, okay, let me just type it in here to be a little bit faster. Then we pass in, we tell someone's name, just tell them like hello, uh, it's a enter your name. Again, it can still be the same statement as before. Then finally, we can print a statement that says, okay, this one I'm going to just reuse this here. So I'll just copy and we can paste it there. So now it says hello, name and everything, right? So this code, what you can see here, this is code that is now modular. So all we need to do is we need to call the greet user function, greet underscore user, just like that, and we run our code. You can just enter Jack for the first one and Jack for the second one. You see, nice to meet you, Jack. But the difference between the two is that the code that we have that is modular, this code is reusable, but the one that we had before is not reusable. So why do we need to avoid what you call monolithic code? So I want you to imagine that you're building an entire house in one giant room. Again, that sounds chaotic, right? The reason for that is because even if you compare that with Python, if everything is in one file, then it becomes hard for you to maintain, test, and even reuse some of those parts later on. So again, you just have like one giant file. In this case, when code is not modular, one giant file is like a single room house. But modular is when you have a well organized building that also has some labeled rooms and everything that is going to make it a little bit usable and less chaotic and more maintainable. So with functions as well, as we talk about modularity, the other issue that we talk about is clean code. Clean code is really, really, really important. We don't want to be in a position where you're writing code that is unmaintainable and code that's sort of just chaotic again. So functions help us break up tasks into logical units. You can call them when they are needed, and you can also test them easily and even reuse them in other projects. The same thing as this greet user function that we just created here. We can reuse this function as many times as you want. And in this case, we're looking at modularity and clean code and reusability within the context of a single file. But when we're talking about modularity, we can still do the same, but we can have different files that are doing a lot of these things. Now, I want us to try something here. So we're going to just comment everything out here, and we're going to write some other code. So we're going to write a function. Let's call this function add. And the function takes in two parameters, A and B, and all it does is it just returns the sum. So remember, when we talk about reusability, using the return the return keyword is important for reusability, because that means the function still holds the value. It can return something that you can reuse later on. So using the return keyword is important as opposed to print, right? So we can go ahead and define another function. Let's call this function something like subtract. And this subtract function can also take in two parameters, A and B, and it will also return the once you've subtracted the resultant after subtracting these two values. So we do that as well. And what we'll do, we're going to define another function. We're going to call this function main. And what's the entire function, the entire function or purpose of this main function is to execute the two functions that we have from before. So it can print the first function. So we call the first function and we give it its arguments. Then we also call the second function, which is subtract, and should be subtract. Then we're also going to give it again, I'd say 3 and 6 as its arguments. Remember, arguments are the ones that we pass in when we are calling the function. Then parameters are the ones that we pass in during function definition. So once you've done that, all we need to do in this case, we just need to call the main function only at this point. So if you call main like that, and I'm going to clear and run our code again, you see we get the result. We get 6 for the addition, and we get -3 for the subtraction. Again, this is a case where we have clean code, because what you can see here is we have all these functions that they're doing everything. We don't have a lot of chaotic statements in between that are trying to, print each of the functions separately. We are doing all that in one main function that we use to execute every other function that we have. And you're going to encounter this in many cases when you're talking about modularity and code usability and clean code that doesn't have a lot of chaos, that is also easy to read. We use the main function to help us to do this. So what the one thing that you also need to take note is you shouldn't, or you do not write or basically rewrite the same logic everywhere. That is something that is really key. Remember, if you write the same logic everywhere, your code becomes difficult to maintain. If you can relate the same logic everywhere, then that means that, or rather, if you see yourself doing that, it means that you should encapsulate that logic in a single function. Then you can reuse that function. So extract the reusable pieces into utility functions, or you can also create helper modules. So this is how utility functions ideally look like. So I'm going to create a new file here, and I'll just create the file from the terminal. And again, if you're using, since you're using, most of you are using Visual Studio Code, to create a new file, you'll go to the top right corner. Again, this is not the same, but if you go to the top right corner, you go to file, you can open new file here. So okay, let me just create a new file, and okay, should get an option to create a new file. I don't want to create a new file. Actually want to open file instead of create. So I should say new. Yeah, new file. Then this is the new file. And I'm going to, okay, we're going to write, this new file is the one that we're going to be using. So what we'll do here is we're going to call it a utility file. And we'll do the same thing that we've done before. We're going to define a function, and it's going to be a grid. So a grid function should be a grid like this. Ooh, okay, then it gets in the name, so we pass in the name as the parameter, then we call, rather we print the output of that function. So once we do this, there are a few things that we need to take note of at this point when you're using this utility functions. When you're using utility functions, the purpose is for you to reuse those functions later on. So if you need to reuse those functions later on, then it means that you need to sort of import them to other files, right? So to help us do that, this is what I'm going to do. So this is actually really confusing. So I'm going to just cut this. I'm going to delete that file. Let me just manually create my file here. I'll call it utility.py, and I'm going to go to utility. This is where we're going to have the code that we just wrote. So this is what we have. Here we should return the output actually instead of just printing it. So we should return. Again, the reason we're using return is for reusability purposes, as we know, because the function is going to return something. So if you need to use this function, we can come to the modular part here, and we can easily import this function. So what we'll come and say here is, from utils, you always import at the top of your file. So I'll come here and say from utils, then I'm going to import the function. The function is called grid. So I can just say that. I called it utility instead of utils. Okay, we can rename this, and I'll call it utils. Yeah, that's good. So from utils, we're going to import this function that we just called grid. Where is it here? And to reuse that function, all we need to do is we just need to call the function. So I can come here and call the function grid, and I'll pass in maybe my name. So let's say I pass in my name there, and we need to print this out because remember we're using the return keyword on the other side. So, okay, what we're getting was never closed. So we're calling greet. Okay, yeah, we're good. I'm not sure where that error came about, but we can call our file now, python3 modular.py. If you call this, you see it says hello Bonaventure, and this is the statement that we had given here. Again, just to prove that this is how it works, we can just hello, how are you, something like this. So again, remember we're using it here. So I'm going to clear this and we run it again. You see it says, hello, how are you, Bonaventure? And this is because we're using we're using modular code. So our code is modular and it's also reusable. So when we talk about utility functions, this is what utility functions do. Utility functions are functions that you can reuse. So instead of having the logic for a specific task all over, we can just confine it to a specific file or function, and we can import this to any other file that we want. You can still do the same for this modular. You can import, add, and subtract. You can import all these other functions to other files, and you can also reuse them there. So that is one of the key things that I wanted us to learn about on this lesson, about how to write clean code, modularity, and reusability. But however, the main thing that one other thing rather that I can add on top of this is how important it is for you to know how to organize your code files. So when you're building an application, your application of course is going to need a lot of files. As the application grows, it's going to need a lot of things to sort of, rather, a lot of functionalities. So as it grows, you need to start splitting things into files. So for example, you need to recognize what your main file is, or the file that executes everything else. You can call it a different name, and then you can have utils as we have here. If you have a different modular or functionality for databases, you can create another file and call it maybe databases.py. We have models. You ideally, you get the point here. Every other functionality, you need to split it into its own files, but each file needs to have a clear purpose that it is doing. When we start building bigger projects, we're going to implement this concept to see what it does. So again, clean code has to be readable, it has to be predictable and well documented. So this is where documentation comes in. Documentation is also an important thing. So what I'd like you to do is I'd like you to go ahead and look at what we call the PEP 8 PEP 8 style guide. So PEP 8 is Python's style guide. You can just write it here. This is Python's style guide. So what this guideline does, it helps you write clean code. It teaches you about documentation, the length of or what the maximum length of each line of code that you write should be. It helps detect a lot of things that might be, or a lot of mistakes that you might make in your code. And to even help you further, if you're using Visual Studio Code, you can go to the extensions part and you can I'd like you to install Fleck 8. So Fleck 8 is an extension that helps you, or rather goes through your Python code, and it tells you where you have made some mistakes or where your code is not following the Pythonic style guide, and it also shows you how you can make the corrections on that. So make sure that you do this. There's a lot more that you're going to learn on how to write clean and modular code, but these are sort of the main things that I thought I should mention as we proceed. So going to look at many of the other things as we proceed. Okay, thank you everyone for joining. I hope you've been able to learn a thing or two from this. I'll see you in the next one.